Hello, my name is Aaron Gonzalez,
I'm Daniela Ornelas.
and we're going to be talking about neural networking. So the definition, neural networks is an interconnection of neural cells with experienced networks can learn as feedback strengthens or inhibits connections that produce certain results. Computer simulations of neural networks show analogous learning. Neural networks can also be a hardware or software that attempts to emulate the processing patterns of a biological brain. So similar to how brain works, it starts from nothing and over time you feed it information and it develops into a smart computer.
The history of neural networks. Warren McCulloch and Walter Pitts were the first people to create a neural network in 1943. They had written a seminal paper on how neurons could help work and model their ideas by creating a simple neural network using electrical circuits. With the breakthrough, they were able to research neural networks in two areas: the biological process in the brain and the application of neural networks to artificial intelligence.
Okay, so here we have the most basic example of a neural network. We have the inputs, the hidden layer, which is where all the working and learning does, and the output. So what will happen is, you'll create an input, and the system will run all through its algorithms to figure out what should be taken to the next step and what shouldn't be at all. And once that process is done, it is sent as output and you have your results.
How do they work? So the neural networks use algorithms to recognize hidden patterns and correlations in raw data. A neural network includes an input layer, an output layer, and an in-between layer. The layers are connected via nodes, and the connections of the nodes are what form a network. The neural network is the interconnection of nodes.
So why are they important? Neural networks are important because they help people solve complex problems in real-life situations. Neural networks can learn and model the relationships between inputs and outputs that are nonlinear and complex. They reveal hidden relationships, patterns, and predictions, and model highly volatile data and variances needed to predict rare events, just like the stock market. And neural networks can improve the decision process.
There are different types of neural networks. There's the convolution neural network, the recurrent neural network, feed-forward neural network, and the autoencoder neural network. So the first one, the convolution neural network, has 5 types of layers. Each has a different purpose, like summarizing, connecting, or activating. The recurrent neural network uses sequential information such as timestamp data from a sensor device or spoken sentence composed of a sequence of terms. The feed-forward neural network what it does is that it uses one layer and then it connects it to every perceptron from the next layer, and information is passed down from one layer to the next in a forward direction. The autoencoders seek to model the inputs themselves, and it considers the method unsupervised. Autoencoders destinize the irrelevant and insensitive. Relevant?
So who can benefit from this? Life and sciences. Why? Health and life sciences organizations use neural networks to enable predictive diagnosis, biomedical imaging, and health monitoring. And who knows, since there's such a similarity between the human brain and the way that these nodes fire in a network, it could even be a way for us to model how to help the human brain or how to create more diagnosis. Manufacturing. Energy and manufacturing companies use neural networks to optimize supply chains, automate defect detection, and forecast energy needs. This can raise our production value while lowering our costs. Banking. Banks use neural networks to detect fraud, conduct credit analysis, and automate financial advisor services, just like the stock markets. And government. Public sector organizations use neural networks to support smart cities, security intelligence, and facial recognition.